Welcome to my YouTube channel, Showmo's class. Today is the second lecture of the solvation of ODE second degree by power series method when x is equals to 0 is an ordinary point for this given ODE. So we solve here an ODE second degree by power series method. When x is equals to 0 is an ordinary point. We have already described what is ordinary point in my previous lecture. So let's start. So working rule. So how to solve the ODE second degree by series method? Let's start the working rule. Step 1. First of all let the differential equation be y double dot plus px into y dot plus qxy is equals to 0. Call it number 1, equation number 1. Here x is equals to 0 is an ordinary point for this DE1 for 1, that is px and qx are analytic. This is the definition for the ordinary point at x is equals to 0. Now this is step 1. We call this as a step 1 to check whether the equation the point x is equals to 0 is analytic or not. So we say this as step 1. Step 2, let y is equals to c0 plus c1x plus c2x square plus dot dot plus cnx to the power n plus dot dot, that is this is cn x to the power n running from 0 to infinity is the power series, is the series solution for 1. Okay. Now step 3. Differentiate we call these as 2. Differentiate 2 times, because this is order 2, so we differentiate 2 times to get dy dx and d2y dx2. Here, so dy dx is equals to, if we differentiate this, so it will, so we will find it is sigma n equal to 1 to infinity n cn x to the power n minus 1, and d2y dx2 it is equals to sigma n from 2 to infinity n minus 1 cn x to the power n minus 2. Okay, this is step 2. Step 4, step 3, this is step 4. Put the values of y dy dx d2y dx2 in the given equation 1, in the given equation 1, and and simplifying the coefficient of x to the power 0, x to the power 1, x to the power 2, x to the power n, dot dot. Step 5. After equating the coefficients of x to the power 0, x to the power 1, x to the power 2, x to the power n dot dot to 0, since the right hand side of equation 1 is 0. To get the value of c i's in terms of C0 and C1. Step 6. Put them, that is C n greater than equal to 2, which we get from step 5, to the equation 2, to get the complete solution, in terms of C0 and C1. So here are 6 steps which we have to follow to get the complete solution y is equals to this sigma cn x to the power n of the given ODE. This is the very simple method for finding the series solution for given ODI when x is equals to 0 is taken as ordinary point. So let's start an example, a problem, very important problem. So let's start. Problem problem find the power series solution. Find the power series solution of the ODE x square plus 1 y double dot plus x into y dot minus xy summon 0 in powers of x, that is x is equals to 0, is an ordinary point. Solution. Step 1, given ODE x square plus 1 y double dot plus xy summon 0. So number 1, that is in standard form, y double dot plus x divided by x square plus 1 y dot minus x divided by x square plus y into y is equals to 0. Comparing this plus px y dash plus qx y equal to 0, we have get px is equals to x divided by x square plus 1 and qx is equals to minus x plus x square plus 1. So if we put x is equals to 0 here and 0 here, so no problem for the definition of px and qx. So definitely x is equals to 0 is a nullity. So clearly x is equals to 0 are, so clearly px and qx are differentiable at x is equals to 0. So x is equals to 0 is an ordinary point. So step 1 is to justify that if x is equals to 0 is whether ordinary or not. Basically we solved for the ordinary points. Later we solved in singular for the singular point. So x is equals to 0 is the ordinary point. Step 2, let y is equals to sigma cn x to the power n from 0 to infinity. Number 2 is the solution for 1. Step 3, differentiating twice, differentiating twice, differentiating 2 twice to get y dot is equals to sigma ncn n from 1 to infinity x to the power n minus 1 and y double dot is equals to sigma n minus 1 cn x to the power n minus 2 n from 2 to infinity. Step 4, putting the value of y is equals to sigma cn x to the power n from 0 to infinity, y dash is equals to sigma n cn x to the power n minus 1 n from 1 to infinity, and y double dot is equals to n from 2 to infinity n minus 1 cn x to the power n minus 2. In the given equation, one, to get what we get, x square plus 1 into y double dot, that means sigma n minus 1 cn x to the power n minus 2 n from 2 to infinity minus x into plus x into sigma this n cn x to the power n minus 1 n from 1 to infinity minus x into y. So this is sigma sigma cn n from 0 to infinity x to the power n, it is equals to 0. So we put the values of y dash and y double dash in the given equation to get this form. So this is x square, this is sigma n minus 1 cn x to the power n minus 2 into x square, that is n from 2 to infinity, plus 1 multiplied by this, will get n minus 1 cn x to the n minus 2 n from 2 to infinity. So plus sigma n from 1 to infinity in cn x to the power n minus cn n from 0 to infinity x to the power n plus 1. So it is equals to 0. So we write the all terms regarding in the form of x to the power n. So here x to the power n from 2 to infinity. So here the term starts from x square, and here the terms starts from x to the power 0. So we can write the term x to the power n minus 2 in the form of x to the power n. So we replace n minus we replace n for n minus 2, and also here we replace n for n plus 1. So what I will get, n minus 1 cn x to the power n from 2 to infinity, plus this is important, So we write n from 0 to infinity. So n will be replaced by n plus 2. So n plus 2, this is n plus 1, c n plus 2 x to the power n plus sigma n c n x to the power n from 1 to infinity, and this is n from, if we replace n plus 1 in n for n plus 1, so n start from 1 to infinity, c n minus 1 x to the power n is equals to 0. We put n in place of n plus 1 here. That is, if we n equal to n plus 1, n starts from here 0 to infinity, so capital N is equals to n starts from 1 to infinity, and c n will be replaced by c n minus 1 x to the power n. So once again we replace capital N, small n in place of capital N to get this. So our target is to write the all terms in forms of x to the power n. So which imply, so x to the power, what is the coefficient for x to the power 0? So here the term starts from x to the power 0. Here starts from x to the power 1, here starts from x to the power 1, here starts from x to the power 2. So we get x to the power, we get the coefficient of x to the power 0 from here, putting n is equals to 0. So if we put here n is equals to 0, so we get 2 into 1 c2 x to the power 0. So this is the constant term. Like, what is the power, what is the term of x to the power 1? That means x. So coefficient of x to the power 1 is, we do not get x to the power 1 from this. So we think about these and this. So putting x is equal n, putting n is equals to 1. So we get 2 plus 1, that means 3. 1 plus 1, 2. So 3 into 2. N is equals to 1. So c n minus, so 1. Here from plus n is equals to 1. C1. So here minus, putting n is equals to 1, so C0. So this is into x. Now we write all term from x n from 2 to infinity. So here sigma n equal to 2 to infinity. So basically we simplify the terms of x to the power 0, x to the power 1, x to the power 2, x to the power 3, this, like that. So n minus 1 cn plus n plus 2 into n plus 1 cn plus 2 plus ncn minus cn minus 1 x to the power n is equals to 0. So here the all terms from x to the power 2, x to the power 3. So coefficient of x square is, we call this, so coefficient of x square is, we get from here, putting n is equals to 2. So 2 minus 1 c2 plus 2 plus 2 2 plus 1, C4 to C2 plus 2 plus 2 C2 minus C1. So this is equals to, we write this. So 2 minus 1, that means 3, 1, 2, 2C2, 4 into 3, that means 12, 12C4 minus 2C2 minus C1. This is the coefficient for x to the power 2, that means x square. So similarly we get the coefficient of x cube, x to the power 4, x to the power n. So which is 2C2 plus 6C3 plus C1 minus C0 x plus sigma n square minus n cn n square cn n square cn minus n cn. We write this is n plus 2, n plus 1, cn plus 2 plus ncn minus cn minus 1 and x to the power n, n from 2 to infinity. So this is cancel out. So after all, last of all, we get 2c2 plus 6c3 plus c1 minus c0 x plus sigma from n to infinity 2 to infinity n square cn minus cn minus 1 plus n plus 2 into n plus 1 cn plus 2 into x to the power n. So now we step 4, step 5, equating the coefficient of x to the power 0, x to the power 1, x to the power 2, x to the power n to 0, we get 2c2 is equals to 0, which we get c2 is equals to 0, 6 is equals to 0, to get c3 is equals to 1/6 of c0 minus c1 and n square cn minus cn minus 1 plus n plus 2 into n plus 1 cn plus 2 is equals to 0 for all n greater than equal to 2, which implies cn plus 2 is equals to cn minus 1 minus n square cn divided by n plus 2 into n plus 1 for all n greater than equal to 2. So we get the recurrence, wherefrom we get C3, C4, C5 dot dot dot. So we get C0 is equals to 0, C3 is equals to this, C4, C5 and onwards we get from this relation. We call it 1, 2 and this is 3. So putting n is equals to C3, we already get n from 2 to infinity. So n equal to 2 in 3 we get C4 is equals to C n equal to 2, so 2 C1 minus 2 4 2 square, so 4 C2 divided by 2 plus 2, so it is we are like this 4 into 3, so 12, so which is C1 divided by 12 as C2 is equals to 0. C2 is equals to 0. Putting n is equals to 3 in kothai, in 3, we get C5 is equals to C, we put n equal to 3, so C2 minus 9 into C3 divided by 3 into 2 5, 3 plus 2 5 into 4, so 20. It is equals to, so minus 9 by 20 C3. Okay. So putting n is equals to 4 in 3, we get C6 is equals to C3 minus 16 C4 divided by 6 into 5, 30. So this is and C3 we get 1/6 of, so 1 by 30, so 1/6 of C0 minus C1 minus 16 into C4. What is C4? It is C1 by 12. 16 C1 by 12. So this is 1 upon 30. So this is 8. This is 4. This is 3. So 1/6 C0 minus C1 minus 4 by 3 C1. So 130, 1 upon 6 C0 minus C1 minus 8 C1. So this is 1 upon 180 C0 minus 9 C1. So all these result we put in 2. So putting the values of C2, C3, C4, C5, C6 dot in 2, that is y is equals to C0 plus C1x plus C2x square plus C3x cube plus C4x to the power 4 plus C5x to the power 5 plus C6x to the power 6 dot is equals to C0 would be C0, so C1x plus C2. What is C2? 0. So 0 into x square. What is C3? C3 is 1/6 of C0 minus C0 x cube plus what is C4? C4 is C4 is C1 by 12. So C1 by 12 x to the power 4. What is C5? C5 is 9 minus 9 by 20 C3. So this is minus 9 upon 20 C3. What is C6? Into x to the power 5 plus 1 upon 180 C0 minus 9 C1 x to the power 6. Now we erase this. So we basically separate two terms as a coefficient of C0 and C1. So what is the coefficient of C0? Here from 1, here from x cube by 6, here from what is C3? Sorry, yes, x to the power 5. C5. What is C5? C5 is so let's start C5. What is C5? C5 is equals to putting n is equals to 3. So this is 3 minus 1 minus 9 C3 divided by 6 into 3, 5 into 3 plus 1, 4. So this is 1 upon 20 into C2 minus 9 C3. Oh, okay, 9 C3. What is we put C3 here. C3 is equals to so C2 minus 9 into what is C3? We put C3 is equals to 1/6 of C0 minus C1. So don't put C3 here. So we have to write this for C3. So this is 1 upon 20. C2 means 0. So this is 3, 2. So 3 by 20 minus 3 by 29. It is 40. C0 minus C1. So put C5 x to the power 5. So it is this term. So we put minus 3 by 40 C0 minus C1 x to the power 5. So put here. We don't write C3. Okay. So 1 plus what is the term x cube by 6. Okay. So here from minus 3 by 40 x to the power 5. Here from x to this power 6 divided by 180. So dot dot dot. So here dot dot dot. So into C0. So what is the term of C1? This is x. Oh, this is x cube divided by 6. So this is x to the power 4 by 12. So minus plus 3 by 40 x to the power 5, and here minus 9 by 180 x to the power 6 dot 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 x to the power C1. So we write 9 by 180 is equals to 1 upon 20. So this is the series solution for the given ODE. So this is the given, this is the complete, this is the solution for given ODE 1. So we see that this is a power series. So that's all. So thank you very much. If you want to see more math, so please subscribe my channel to inspire me. Thank you.